LeChatelier's Principle Lab, Part 3. So here is our equilibrium system in this one. It's a little bit different. It's just really a net ionic equation where Ag plus from silver nitrate combines with the Cl minus from sodium chloride and forms AgCl solid, which is a precipitate. So let's take a look right at that and see what's going to happen. I have a test tube right here. I'm going to take some NaCl. Maybe I'll take some AgNO3. And the nitrate's going to be a spectator ion. Add about 5 drops right there. And that is a clear solution. And then I have another clear solution of sodium chloride. We're getting a lot of shadows right here, but I think without the shadows you can see that that is a milky white. Now if you look there, there's little chunks and things on the bottom. So it looks like there's also been what we're going to call a PPT, or a precipitate. That is the abbreviation right there. So the next thing we're going to do is we're going to add some pretty strong ammonia. And I'm like, what does ammonia have to do with this system? Well, if you look over here, it says Ag combines with ammonia. The ammonia decreases Ag plus by making this ligand AgNH3 So we're going to remove Ag plus. Which way is that going to shift the equilibrium? And what's going to happen? Let's find out. So I'm going to take this ammonia here. I'm going to add this. Let's see, I don't know if I see a lot happening there. Let's mix that around really, really good. Where did it go? Okay, let's see. Oh, precipitate is gone. Okay, so by removing the Ag plus, we shifted the equilibrium to the left. And what happened to our precipitate? It went away. Okay, or virtually is gone. What if I wanted to maybe bring back that precipitate? I'm going to put the cap on this ammonia. It's rather strong scent right here. I don't know if you can smell that where you're at, but I can. All right, and I'm going to grab some HNO3, which is an acid, and essentially the acid's going to neutralize the ammonia base and bring things back to where they were. So I'm going to cancel out the last step. It's really going to be like adding Ag plus and shift the equilibrium back the other way, and let's see what happens. And we'll put the drops in. Try not to cast too many shadows as I do this. You start to see it get cloudy. And if I add enough, it's not clear anymore, it's milky white. So this is an equilibrium system where you do get a color change going from clear to white, but you're also getting a precipitate change, either going from precipitate or no precipitate. We might have seen things like this where precipitates dissolved and came back in our qualitative analysis lab at the end of quarter 2. So there is our final product, and we're back to having some of that AgCl precipitate. So what's our job with this one? For this lab is really, you're just supposed to figure out, did Cl minus increase or decrease? Did the precipitate AgCl increase or decrease in the first system? And then what happened in the second system? Did it increase or decrease? You're going to write that in. Think about the equilibrium shifts. This is the center point. Does it shift left or does it shift right? And wherever the arrow points to will get bigger. Wherever the arrow comes from will get smaller. The final piece with this lab is just this question: what did you find? Summarize LeChatelier's principle, or you could talk about it in terms of concentration, temperature, shift away from what you add, shift toward what you take away, however you want to summarize that in your words that makes sense to you. And that's really it for that lab right there. Let's go to a homework packet, and we'll show an example of that. And if I look at this, it says, this is page 6 of your homework packet. And it gives you LeChatelier's principle, and then it gives you some directions. And it says, predict the effect of the following changes on the respective equilibrium systems. Answer shift left, shift right, or no effect. And I think I'm going to go right to question 2 for this and show us how we can do this actually pretty quickly once you can start predicting these things. And again, it might take a while to learn this, but we want you to get to the point where you can make these predictions and do that. So the big thing with concentration and temperature is shift away from what you add, shift toward what you take away. If I add something to the right side, it's going to shift to the opposite side. Wherever the arrow points to will get bigger, wherever the arrow comes from will get smaller. If I remove O2, it's going to shift toward what I remove, so that shifts left. If I add CO, which is on the left, it's going to shift right because I'm adding something to the left, so I'm going to shift to get rid of some of it. If I add heat, heat in this case is on the right, so it's going to shift left. If I remove heat, I'm taking heat away, so it's going to shift toward the right here. If I increase or decrease pressure, hey, I don't see pressure in this system. How do I do something like that? Let's look at one other hint sheet right here. And this is a summary of some of the things of LeChatelier's principle, shifting away from what you add, shifting toward what you take away with temperature. But what about pressure changes? This says if pressure increases, it shifts toward the side that takes up less space. And how do you know what has less space? I look at gas because that's what usually takes up the most space. And the one with the least moles of gas is going to take up the least space. If the pressure decreases, it's going to shift toward the side that takes up more space. Okay? So let's just say I have something like one of those sleeping bags and I'm trying to put it in its small little stuff stack. I'm going to put it under pressure and it's going to shift toward to going inside the stuff sack. I'll put pressure on it and it will shift toward the side that takes up less space. Okay, and then when I take it out, what happens is it's being relieved of all that pressure, the pressure decreases, and then it spreads out and it opens up for you. So this is kind of something that naturally happens, and let's take a look at our question and see how that applies back here. So if I look at this question right here, I count moles, but I count moles of gas. I have 2 in this coefficient and I have 1 in this coefficient. There's 3 moles of gas on the left, there's 2 moles of gas on the right. The heat doesn't count as a mole of gas in either way. So it's 3 versus 2. If I increase pressure, it's going to shift toward the side with less, so it's going to go from left to right. If I decrease pressure, it's going to go from the side to 2 to 3, and it's going to go to the left. So those are 3 things in equilibrium shifts: concentration changes, temperature changes, or changes in pressure. And you can predict which way equilibrium shifts, and then wherever the arrow points to, those things will get bigger. Wherever the arrow comes from will get smaller. So look at pages 6, 7, and 8. Shift right, shift left. The last page has a couple other questions in addition to that. See what you can do with that, and then we'll check that and make sure you're good to go before we get into some other things.